Now coming to measuring of tan delta for XLP material, insulator and oils. This is the equipment which is used for measuring tan delta. Okay, so this is Midas mobile insulation diagnostic and analyzing system. So this is the basic window for this one, and if you it's a simple window based system. So if I close this one first, so this is how you go to this. So here is this icon here which you double click and you will have a window. It takes time to boot up this main menu of this window. So let it load first. Okay, now when you come for exam or repeating this experiment, you will have a window always open for you like this. So we have, so here it is, you will set the voltage and then frequency is default 60 Hertz here. Then this mode you don't need to change, it's already set there. So what we'll measure here is the applied voltage, RMS voltage, and you will get tan delta. Then you will have capacitance and resistance values here. So this will be all recorded here. So whenever you have a value to be recorded, you just press this record button here, so it will record that value. So this is the basic function of these are the basic recording parameters for your any test which you'll be doing with this one. So this has multiple cable connections, like you can see here, which you will not do. As I told you, they will be all provided already. The instrument will be set up for you. So you can see these two cables going here, coming out of this instrument. So this yellow one will be a high voltage connection, as it is connected here. So you will have high voltage connection, and then the other wire, black wire, will go as a ground connection. So as you have been doing experiments in high voltage, so upper one will be at high voltage, this yellow connection will go as a high voltage connection, and the other lower one will be a ground connection. So that's a return path to the instrument there. Now this is the basic set of the instrument. So like here we have this one, this will be for measuring this tan delta for an XLP insulation. We have a plane to plane geometry, so you'll just insert this here, and as the connection is already done, so you will have this between these two, you will have this between these two plane electrodes, you will insert this XLP insulation, and then here you can just, you have to make sure that this is these electrodes, they are touching the insulation properly. So we have here a wheel rotating handle, so you can make this tight. So as I go on making it tight, you'll see the gap is coming closer. So make sure that this gap is, electrodes are sitting tight here. So it's all set now. So I will go back to the instrument panel there, which is here. So for starting the experiment, I need to, this is a safety switch here. So once you switch on this one, you see red light coming on the right side of the panel. So that means indicating there is a high voltage. So you have to be careful. So you should not go beyond this control system after you energize it or you press it. Once you press it, so you can select the voltage. It's a finger touch here, so you can enter the voltage. So we'll be doing at 2 kilovolt, so it will be 2 1000, and then you can press OK. Then once you have ready this one, so press this one, high voltage on. So it does many calibration things there. So you will have already as a doctor explained you the theory. So these variable resistors and capacitor, they are adjusted, trying to adjust itself. So once they become very bold like it has become now, so you can press record button here. Okay, now I will just release this button, so high voltage is automatically switched off. So you have values for this insulator, XLP insulation. So at 2 kV it is 10 delta is 0.0049 and capacitance is 1.29 picofarad. 420.8 gigahertz is the resistance and frequency is 60 hertz. So this is the first part of the experiment, which is already done, like for XLP insulation. Same procedure for operating procedure will apply for all other tests which we are going to do now. The second part of this experiment is finding 10 delta value for an insulator. So this is the high voltage connection coming from the top, coming at the top electrode of the insulator. So this is a post ceramic insulator, so it is in good healthy condition, there is no defect at all. So and the black wire which is coming from the same instrument, so this will be going to the ground connection here. So our insulator, it is between two electrodes, one top at high voltage and this will be at the ground. So we'll be applying. So this is a clean dry insulator, no defects at all. So we'll be going back to the instrument and then measuring this 10 delta value again for this one. So we are back at the instrument panel. So this safety switch, press on, and then you just okay, increase voltage back to, so increase back voltage again to 2 kV, 2000 volt, press OK, and then press high voltage on. So it will try to calibrate again and it is trying to measure. So once this bar is red here, that means high voltage is on. So you'll see these are still very dim numbers. So once they become very bright green ones, that means the values have stabilized and you can record that time. So you'll just press this record button that time to record those values in the second line here. So they are still adjusting the values there. So basically our factor is this one, 10. So it has become very bright now. So still they have gone off, some adjustment still. Okay, they are now so these values are recorded here. Okay, so this is for the insulator when it is clean condition. So this is its capacitance, this is 174 giga ohm, so very high value at frequency of 60 hertz. So what we'll do now is make the insulator defective. Like how we make the insulator defective, we'll use this water here to spray, so make insulator bit defect so that there are leakage currents from the top. So we'll make it wet and you'll see there is decrease in 10 delta values. So let us start the measurement again after we make this insulator wet. So I will just again measure, enter the voltage of 2 kilovolt again. Okay, press on, then go to on here. So it is again trying to measure the values, trying to adjust itself. So once they stabilize, become very dark green as in the above. You can see the tan delta value has increased from the previous reading. So even the capacitance and resistance is also decreased from 100, so 300, some 174 to 14 gigahertz. Giga ohm, sorry. Still taking time. Okay, we can press record now. Okay, so release this button and this high voltage is automatically switched off. So you have now for the values which we recorded was first for insulator 10 delta value, this XLP insulation, then this was insulator which has got this when it was in good condition. Then you can see here the tan delta value has increased for a defective one where we put water and it is there are some leakage current, so that is why this value is pretty high. Even the resistance, you can see this was previously 174 for a good insulator and now it decreased to a 14.89 gigahertz, so giga ohms. So this is how we are measuring, can tell you the condition of the insulator based on the resistance and tan delta values. Okay, the third part is testing of tan delta for an oil. So you have this oil test cell which has got two spherical electrodes. The gap will keep fixed at 2.5 millimeter. So first, for finding C0 for air, that again we'll keep this open, nothing inside this test cell. This is just empty test cell, and we'll have high voltage being connected to this part. So this is the yellow wire which I mentioned you before. It is coming here and being connected at one electrode. The second electrode, this black wire from the instrument will go. So this is your total setup is connected like this. So you will have this test cell empty. Now we'll be finding, say, tan delta for the air. So this will be C0 for your measurements for finding the permittivity. So you'll have this, you will repeat the same procedure as mentioned earlier for the earlier two cases. So find whatever value of tan delta there. Then we will have this test cell filled with the oil. So we have transformer oil here. So we'll pour this oil here inside this one. So again, you should make sure that they are fully dipped. Both the cells are, these electrodes are fully dipped in the oil. Again, close this lid here. Okay, so repeat the setup with the oil, previously without oil, just for the air, then again filled with oil, and then you will have tan delta for this transformer oil. Now again we need to take the measurement for defective type of insulation in this oil in it. So we'll add some impurities. So impurities again we'll be using as this water, some droplets of the water, so they will create a moisture inside. So we'll see after you repeat the tan delta value, tan delta measurement for oil with some moisture in it, you will see a lot of difference in the values there. So this completes the experimental part for all this tan delta measurements. So we did first for the XLP, then for the insulator, and then for the oil. Oil was under first for air, and then for oil, and then with oil with impurities. So again, thank you very much for this video. Okay, if you have any concern, any doubts, please write an email to me. I'll be happy to address your any queries. Thank you very much. Bismillahirrahmanirrahim. Assalamu alaikum. This is the oil dielectric testing machine. Okay, it's called kit also. So it works on 220 volt input, and the output is say up to maximum of 80 kilovolts. So once there's a power switch here, so once you press the switch on, so it will automatically turn on and you will have multiple displays here. These can be selected up down by this menu here. So we usually do it on single test section. So once you select this single, then press OK. So you are ready to test now. And what the procedure is like, whatever gap you can set inside the oil test, that I will come later. So once you press OK here, so you'll take less than say one reading. So then say press on. It will go on increasing till there is a breakdown inside the test cell. So once there is a breakdown, so it will record that value. It will stop at that breakdown value. So this is the value indicated, 19.7 kilovolts. So whatever the gap was set there previously. So our experiment will have 3 gaps, variable gaps. So here you can see the main important thing is, because you are in this in high voltage generating equipment, so it gives maximum up to 80 kilovolt. So safety factor is very important. Now say if I press this power main menu and then press single test, okay, then if I press switch on, now if I open this lid suddenly, so the high voltage is turned off. So I'll say it will switch off the high volt. That's very safe. That is most important safety factor for this one. Now you can see this test cell, it has 2 electrodes, 1 and 2. So in between whatever the gap you can set that is we'll be doing at say 0.51 and 1.5 millimeter gap. Okay, so the gaps we can select by using this is called feeler gauge. So here we have thickness mentioned here. Say here this is 100, means here this is 1 millimeter. Then we have each say 20. So each is a this 20 that is 0.2. So we'll be doing 1. So the combination of these two, this 20 and 100, will make a gap as 1.4 millimeter. So all of them in millimeters. So what is the procedure like? Decide what gap you need to keep. Say for example, I'll keep 1 millimeter gap here. So this is my 1 millimeter gauge. So I will just first I'll need to bring those gaps closer. So I'll just open the lid here. So I'll bring the gaps closer here. So you can increase, open the gap or close the gap. So you have to first initially reset it. So once they touch each other, they make a sound. So this is gap is set to 0. Now I want to put it 1 millimeter. So I'll just reopen it little bit, push this gap inside. So open up a little bit more. So this is, it should move freely within the gap. So the gap is set for 1 millimeter. So then you close the lid again for the oil. So close it, then close the lid and say I'll go back from the start position. So off, then I will switch it on again. So it takes 5 seconds to boot up. Okay, it has some self-test. So select, say go to single test, say OK, and then you can say start the test. So 1 reading, press start. So it will go on increasing till there is a breakdown in the gap. So our gap is set at 1 millimeter. So this is the breakdown value for 16 point for 1 millimeter gap. The first reading is 16.2. Then we go again to main menu, press, then again go to, we'll repeat 3 times for each gap. Say second, press 1 and then start increasing. It's all RMS. So this second reading is 13.7. So we need to repeat once more. So to get a good reading for average of all three, so press OK, then single test, then press start test again. Less than 1 reading, so go again. So the voltage is increasing. So 14 kV. So we have three readings, 13 point something, then there was 16.7, 14.1. So we'll take average of all the three readings. So this will so then you change the gap to another gap, say 1.4, then you can go 1.8 or 2 maximum. So you'll be doing for each gap 3 times, so 3 gaps, then you will plot against gap versus voltage as explained in the lecture by the doctor. So this is the main procedure for oil machine. So in case this video is not clear to you, so you can always write me an email or explanation, asking for explanation of any doubts you may have. So just a brief out. So this is the machine here. So once you come to the college for examination or whatever, refreshing or repeating of the experiment, you're welcome anytime after the college reopens. So this is your gap, this equipment, this is the test cell. So we have mineral oil filled, this one. So as mentioned, these are the feeler gauges. Okay, shukran.